Vectors are essential for graphic and game development. One of the operations that we can perform on two vectors is the dot product. Let's take two vectors, A and B. We can calculate the dot product by multiplying the corresponding components of each vector and summing them all, or by multiplying the length of the two vectors by the cosine of the angle between them. The result is a scalar that represents the projection of one vector into another. But things become more interesting if the vectors are both normalized. A normalized vector is a vector of length 1. We can normalize a vector by dividing each component by its length. Now let's replace both length in our formula with 1. And since multiplying by 1 doesn't change anything, we are left with the cosine of the angle between the two vectors. If the vectors are pointing in the same direction, the angle between them is 0, and the cosine of 0 is 1. If the vectors are perpendicular to each other, the angle between them is 90 degrees, and the cosine of 90 is 0. And if the vectors are pointing in opposite directions, the angle between them is 180, and the cosine of 180 is minus 1. And any other angle will give us a value between 1 and minus 1. Let's take two characters, a player and an enemy, and we would like to know if the player is in front or behind the enemy. The first thing we need to do is to calculate the direction from the enemy to the player. We can calculate the direction by subtracting the enemy's position from the player position. This will give us a vector that goes from the enemy to the player, and its length is equal to the distance between them. Then we normalize the direction vector, aka making its length 1. Then we calculate the dot product between the direction vector and the forward vector of the enemy. And this is how the dot product result changes when the player's position is changing. If the two vectors are facing the same direction, the result of the dot product will be 1. If they are pointing in opposite directions, the result of the dot product will be minus 1. We can set a threshold, in this case 0.85. If the dot product is greater than or equal to the threshold, we know the player is in front of the enemy, and we can perform an action such as making the enemy follow the player. We can also do the opposite if we set the threshold to negative 0.85 and check if the dot product is less or equal to the threshold. If our condition is true, we know that the player is behind the enemy. And here we can perform an action like a sneak attack. We can do light simulation if we calculate the direction from an object to the light source, normalize it, and calculate its dot product with all the normal vectors pointing outward from the object. If the vectors are pointing in the same direction, the result will be 1. If they are pointing in opposite directions, the result will be minus 1. We will remap the values to range from 1 to 0, where 1 represents white and 0 represents black. And let's turn on the light. We can make effects like Fresnel if we calculate the dot product between the normal vectors and the vector coming from the object to you, the viewer. The result will be 1 at the center and 0 at the edges. And let's flip the values.